This is going to have two parts. I went to go pause it to check something, and then I accidentally hit publish. So that's my bad. We'll see if I can merge them. Probably not. But anyway, so I'm going to pick up where I left off with the last video, part 1. This is part 2 of lesson 3.6. So the first thing I'm going to do is write this as the cosine of 7x squared plus 1, all raised to the 4th power. So when I do the derivative of this function, I'm going to do d dx of cosine of 7x squared plus 1 all raised to the 4th power. So the very first thing I'm going to do is I'm actually going to deal with this power. Then I'm going to move to the front and do 4 times the cosine of 7x squared plus 1 to the 3rd power, okay, times the derivative of the inside, which is d dx of cosine of 7x squared plus 1. All right, and so I'm going to copy this first part down. So 4 times the cosine of 7x squared plus 1 cubed. All right, times the derivative using the chain rule again, right, a second chain rule. The derivative of cosine is negative sine, but I'm going to evaluate that at 7x squared plus 1. And then don't forget to multiply that by the derivative of that inside piece, okay, which is going to be the derivative of the inside, which is 14x, and that's it, okay? I'm going to pause for a second, hit the right button, pause. Okay, so now I'm going to kind of put it together for k prime of x. I'm going to multiply 14x times 4 and times that negative to get negative 56x times sine of 7x squared plus 1 times the cosine cubed of 7x squared plus 1. All right, so that is going to be my derivative. Okay, let's do some work with our position, velocity, and acceleration like we've done the last few lessons with some of these new derivative rules. So we have a position function given by s of t equals sine of 2t plus cosine of 3t. What is the velocity of the particle at time t equals pi over 6? We need to find velocity. Again, velocity is the derivative of the position function. So that's d dx of sine of 2t plus the cosine of 3t. All right, so using my chain rule, the derivative of sine is cosine. That's the cosine of that inside function 2t. But remember, times the derivative of that inside function. So the derivative of 2t is 2. Then the derivative of cosine is going to be minus sine of that inside function times the derivative of that inside function of 3t, which is 3. So if I want to make this simplified a little bit, I'm going to write 2 cosine of 2t minus 3 sine of 3t. So that is my velocity function. It wants us to find the velocity of this particle when time is pi over 6. So I'm going to plug in pi over 6. So I get 2 times the cosine of 2 times pi over 6 minus 3 times the sine of 3 times pi over 6. Okay, so again, it's going to be doing a little bit of our trig formula sheet, which I should open that up since we're going to use it. So I'm going to go to the pre-calculus trig. There's our formula sheet. Okay, so we have the cosine of 2 pi over 6. Now, 2 pi over 6 is the same as pi over 3. The cosine of pi over 3, cosine pi over 3 right here is 1/2. So I'm going to evaluate that to be 1/2. So 2 times 1/2 minus, I have 3 times the sine of 3 pi over 6. 3 pi over 6 is the same as pi over 2. So I need the pi over 2, which is a quadrantal. Remember, sine is in the y value. So the sine of pi over 2 is 1. So that's going to be 3 times 1. Okay, so half of 2 is 1. 3 times 1 is 3. So our velocity at time of pi over 6 units is -2. Doesn't say any units, so units per time. Okay? All right. Let's do one of these where we have just some actual functional values, not any actual functions. We just have the inputs and the outputs. So we have h of x equals f of g of x. So we're trying to find h prime of 1. Well, let's first find h prime of x. That's going to be equal to the derivative of f of g of x. Okay? So that means we're going to have the derivative of f of x, which is f prime evaluated at g of x, times the derivative of that g of x, which is g prime of x. All right, we're going to plug in 1 wherever you see x. So f prime of g of 1 times g prime of 1. So we can do that here. So g of 1 is 4. So it's going to be f prime of 4. Stop going away. Times g prime of 1, which is g prime of 1 is 3. Okay, almost there. F prime of 4 is 7. So 7 times 3 is 21. So h prime of 1 is 21. All right, now the very last thing. The last thing is using the chain rule, using Leibniz's notation, okay? Now, when we do this, it's going to be a little confusing, but that's okay. Just know that this is used mostly with physics. So those of you that are interested in doing more physics, you'll see this at some point in your physics courses in college. But ultimately, what we're going to do is instead of having f of x, we're going to have the letter y. And instead of having g of x, we're going to have the letter u. All right, so those are going to change kind of how we view it. And then we're going to end up using this formula that says the derivative of your y equation, so dy over dx, is equal to the derivative of your u function, so dy over du, times the derivative of derivative of the y function times the derivative of the u function, so du over dx. Okay, so that's what we're going to be finding in these two examples. All right, so let's go ahead. First, you'll notice we don't have f of x anymore. We have y. And I'm going to write down that u is always the inside function. So I'm going to write down that u is x over 3x plus 2. Okay? So in order to do this, I have to find these two things, dy over du and du over dx. So the first one I'm going to do is du over dx, which is the derivative of x over 3x plus 2. So du over dx of x over 3x plus 2. Now this is going to be where I use the quotient rule, all right, the quotient rule from our 3.3 lesson, which says to find the derivative of the numerator, which is 1, times the original denominator, minus the derivative of the denominator, which is 3, times the original numerator, all over the denominator squared. So 3x plus 2 squared. Clean that up a little bit. We're going to get 3x plus 2 minus 3x over 3x plus 2 squared. And the 3x's are going to make 0, so you get 2 over 3x plus 2 squared. So that is du over dx. I'll highlight that to make sure you understand. We found one of the pieces. Okay. The other piece is going to be dy. Oh, hold on one second. Yes. Okay. Awesome. Let me not box it, but just show you that we're hit like I have a breaking point. The other thing that now I'm going to write is y equals u to the 5th power, right? So if I replace this x over 3x plus 2 with u to find dy du, right? dy over du, that's going to be the derivative of u to the 5th power, which is something we did in our first lesson on power rules or derivative rules, the power rule, which is 5u to the 4th power. Okay, so now that's our second piece. Highlight that one for you. To finish the problem, we need to multiply, right? If I go back to the formula, dy du times du dx. So I'm going to multiply for the derivative of dy over dx. It's going to be 5u to the fourth power times 2 over 3x plus 2 squared. Now, I'm going to say this, and I know it's always confusing when I say it, but this is the answer, but it's not the answer. The reason it is the answer is because you've done the process to write dy over du times du over dx. But the reason that it's not the answer is because you have to write the answer using the same variables that were in the original problem. So if you remember that very first thing I did, where I made u equal to x over 3x plus 2, all right, I need to replace or substitute that back in where it's cu. So it's going to be 5 times x over 3x plus 2. So the fourth power times 2 over 3x plus 2 squared. You could leave it like this. The textbook has it where it does a little more simplification, so I'll go ahead and do that. X to the fourth power is going to become, so 5 times x to the fourth power over 3x plus 2 to the fourth power. And now it's going to put all of this together to become 10x to the fourth power over 3x plus 2 to the sixth power. So that is dy over dx. All right, let's do one more like that. So one more where we're using Leibniz's notation. All right, so again, I'm going to write this as y equals the tangent. I'm sorry, let me write this first. That u is equal to 4x squared minus 3x plus 1. All right, so I'm going to first find du over dx, which is the derivative of 4x squared minus 3x plus 1. All right, this is something we did a few lessons ago. The derivative of 4x squared is 8x. Derivative of minus 3x is minus 3. Derivative of a constant is always 0. So there's our first piece. That's du dx. Then I'm going to write down, right? I'm going to write down that y equals the tangent of u. All right, so I need to find dy over du, okay, which is going to be the derivative of the tangent of u. All right, go back to your last notes. We have the tangent, derivative of the tangent is secant squared x. So we're going to write this is equal to secant squared of u. All right, that's my second piece. And now I'm going to multiply them together to find dy over dx. So dy dx is equal to secant squared u times 8x minus 3. Okay, remember this is the answer, but it's not. We have to replace u with 4x squared minus 3x plus 1 times 8x minus 3. All right, so to simplify it, you get 8x minus 3 times secant squared of 4x squared minus 3x plus 1. That is dy dx. Again, I apologize for this being two pieces. I'm going to try to push them together, but it's probably not going to work out. So just make sure you watch both parts for this lesson.